My lab is working on optical imaging of the brain. Specifically, what we have developed is a non-invasive way of intracranial pressure sensing. So what that means is everyone is familiar with a blood pressure cuff. You know, blood pressure relates to your cardiac health. Pulse oximeter that you clip on the finger tells you about how well is your blood saturated and tells you about lung function and health. But for the brain, we really do not have an equivalent. Pressure inside the head, that's called intracranial pressure, can only be measured currently by drilling a hole and putting a probe inside the brain. So what we have developed is a sensor that goes on the forehead, uses optical imaging. It's very similar to a pulse oximeter. And based on data analysis and machine learning, we're converting the signals that we measure optically into intracranial pressure. So the imaging methods that we have developed are called diffuse correlation spectroscopy, and it measures blood flow in the brain. So we place an optical probe, something like this, on the forehead. And what we have done is we took that machine that requires specialized training and one of my students to go in and take the measurements. We've placed that probe on the forehead of children in a pediatric ICU. Those children already have an invasive probe as a ground truth in place. And we've taken data and have shown that we have very good correlation between our optically derived intracranial pressure and the ground truth intracranial pressure. What we have recently found is that we can replace our specialized methods by a rather simple device, a smaller and more portable, that again can be put on the forehead and measures similar signals, but in a much more portable fashion. The research thus far has been enabled by absolutely outstanding collaborators within the department, as well as my clinical collaborators at UPMC at the Children's Hospital. Without them, this research and even just the initial validation study would have not been possible. But the reality is that it's an algorithm that is based on machine learning. In order to find this method in a clinical setting, in a day-to-day use, what we really need is more data. We need to train the algorithm with more patient data to then really show efficacy in a much larger cohort, which means we need buy-in and collaboration from many clinical centers and otherwise very busy neurosurgeons and nurses and so on. One of the hurdles that we're trying to overcome is to really simplify the devices so much that anyone without training can use them. Any patient that comes into a neuro ICU can be monitored by simply putting a device on the forehead, pressing one button, and giving us the data that we need for training the algorithm properly. So I would love to see the method as soon as possible in the clinic, used by everyone, but we are still working on a larger scale clinical translation. What we hear over and over again from neurosurgeons, neurologists, neurocritical care doctors is that non-invasive intracranial pressure sensing is absolutely needed. If what we have developed works as well as we're hoping in a larger clinical cohort, that is the holy grail. And we believe, at the very least, it's better than a hole in the head.